Take a look at another example of exponential decay. A scientist begins with 300 grams of radon-222. After 200 minutes, the substance decayed to 100 grams. Based on this data, what is the half-life of radon-222? So again, we're at this question about half-life. We're saying how long does it take for half of the original amount to remain. So we're trying to find this time. So we're using our exponential growth and decay model. A of t is equal to a sub 0 e to the kt. Our initial amount we see is 300, so we plug that in. A of t is equal to 300 e to the kt. My first thing I need to do is I need to solve for k. I'm always trying to find this function first. I need to figure out the rate at which this is decaying. So I plug in information that after 200 minutes, there's 100 grams remaining. So I have 100 grams remaining is equal to 300 e to the k times 200. I divide over the 300, so I get 1/3 is equal to e to the k times 200. My variable is in the exponent, so I take log of both sides. So I take natural log of both sides, natural log of e to the, I'm just going to write this as 200k. Bring down the exponent, so I have natural log of 1/3 is equal to 200k times natural log of e. Natural log of e we know is equal to 1, so all I need to do is solve for k, so I divide by 200. So k is equal to natural log of 1/3 divided by 200. Now I want to leave this answer. But if you want to have some intuition about what are we talking about, what number is this, we could plug that into our calculator and get natural log of 1 divided by 3 divided by 200. This number is a negative number. That makes sense because we said that with these exponential growth and decay models, if this k is negative, it is decaying. So that's good. We have a negative number. So my general function that I have is a of t is equal to 300 e to the natural log of 1/3 divided by 200 times t. So this is my function that I'm now going to use to figure out the half-life with. So for half-life, I want half of the original amount remaining. So I want there to be 150 remaining. My initial amount was 300, and my thing over here is e to the natural log of 1/3 divided by 200 times t. I always need to get the exponent by itself, so I divide by the 300 first. This simplifies to 1/2 is equal to e to the natural log of 1 divided by 3 divided by 200 times t. To solve for the variable in the exponent, I take log of both sides. So I have natural log of 1/2 is equal to natural log of e to the natural log of 1 divided by 3 divided by 200 times t. Bring down the exponent. Natural log of 1/2 is equal to natural log of 1 divided by 3 divided by 200 times t times natural log of e. Natural log of e we said is always equal to 1. So if I want to get rid of this fraction in front of t, I'm going to multiply by the reciprocal. So what that means is I'm going to multiply by 200 over natural log of 1/3. And I'm multiplying this by natural log of 1/2. And that is equal to my t. So let's go to the calculator. We will type this in. So I will do 200 times natural log of 1 divided by 2. That is going to be divided by natural log of 1 divided by 3. Close the parentheses, and my t is equal to 126.2. So this is the amount of time, and the unit is minutes. So it takes about 126 minutes for only half of the total amount of radon to still exist because it is decaying and is doing this weird chemical process. So if you take chemistry, you'll talk about exponential growth and decay or exponential decay of these radioactive materials.